We're now going to look at altruism and consider whether it is, in fact, a Darwinian paradox. But we're also going to be looking at some phenomena that are related to this general aspect of categorizing behaviors as altruistic or other types of categories. Here's what I mean. So let's look at possible social behaviors that are based on the effects of the relative fitness of two interactants. One is the behaving animal, and the other is the recipient of whatever behavior the behaving animal happens to be engaging in. So there's four possibilities. In the first one, we have you as the behavior engaging in a behavior, and your friend as the recipient of the behavior's behavior, if that makes sense. So suppose you behave in such a way that your fitness is enhanced. And as a result of that, so is your friend's. Your friend's fitness is also enhanced. We call that cooperation. So there are some non-human examples of this that are really pretty interesting. This one, of course, I'm sure is just a setup, but you can see cooperation occurring. The ducklings are distracting the human, and the adult duck is getting the money out of her purse. Okay, whatever. But here is a real example that involves cooperative hunting in Harris's hawk. These guys don't hunt alone, typically. They hunt in, basically, packs, like wolf packs. And they do this in three typical ways. They might engage in successively pouncing on a prey animal until it totally succumbs. Or relay attack. So one will attack, and then the other one will attack, and then the other one will attack, and finally, the prey is dead. Or sometimes some individuals will flush a prey out of hiding, and then the others proceed to ambush it. And this last strategy is shown in this video clip.
When it comes to hunting, most hawks like flying solo, except for the Harris's hawk. These desert raptors love being part of a crowd, especially when they move in for the kill. First, a scout takes the high ground, scanning the landscape with vision thought to be 8 times better than a human's. Then it's time to invite the relatives over for dinner. The first hawk spots the quarry, a jackrabbit. It won't be easy to catch. These hares wrote the book on evasive action. They can run as fast as 40 miles an hour and leap 10 feet. But it may take more than that to escape from the wolf pack of the air. The first hawk flushes the jackrabbit while the others watch for the getaway. So when the rabbit instinctively zigzags away from one predator, it runs straight into the talons of another. And the whole family gets to share in the spoils, though there's always a little sibling rivalry. But the family that prays together will probably stay together.
So by cooperating in that fashion, they can hunt more efficiently. They're more likely to catch a prey, especially as one as fast as a jackrabbit, and they all get to eat something. So cooperative hunting within the same species. Okay, here comes an example of cooperative hunting involving two very, very different species.
These are banded sea kraits. They lay their eggs on land, but they hunt here in the water. They're too slow to catch fish in a straight chase, so they seek prey that is hiding in the nooks and crannies of the coral. Their bite is highly venomous and paralyzes their victims. And on this reef, the snakes do not hunt alone. Shoals of yellow goatfish and trevally are seeking similar prey, and they attract the snake's attention. As one group of hunters searches the reef, they're joined by the other. At least 30 snakes have now joined the caravan. The big fish scare the prey into cracks, and there the snakes can catch them. And anything fleeing from the crates will swim straight into the mouths of the waiting trevally. There's nowhere to hide. As the raiders scour the reef, more and more snakes join the hunt. This cooperation between snakes and fish, spectacular though it is, has only recently been observed, for it only happens on the most remote reefs in Indonesia.
So again, cooperative hunting, but this time involving two different species, and both benefit in terms of enhancing their fitness by feeding. Now, we also have cooperative courtship in some birds. Manakins are notorious for this. It's kind of rare, actually, that we see this kind of thing, but I'm going to show you two manakin species. So in the long-tailed manakin, what happens is a female, and we're looking at a photo of a male, by the way. The female is courted by an alpha and a beta male. So alpha means the dominant male, beta a subordinate male. So it turns out that she's much more responsive if she's courted by these two birds rather than just one. It's advantageous for the dominant male, the alpha male, because once she agrees to mate, generally they will stay mated for a long period of time. Now the subordinate or beta male also gains from this, because he gets to do some sneaking copulations when the alpha male is off somewhere. And if something does happen to the alpha male, he gets eaten by a predator or just dies of natural causes or whatever, typically that subordinate male will now become the alpha male and get to mate with that female. So here we have long-tailed manakins. You can see the female is kind of greenish, being courted by these two males. One's alpha, one's beta, and I don't know which is which. Okay, that's the long-tailed manakin.
This is the blue manakin. He is captain of this team, and he whistles to summon the other members. The team is complete, and the show begins. They are striving to prove that they are the best team of acrobats in the neighbourhood. A female arrives. She is going to get a close-up view of the performance from the actual dancing perch. If she's sufficiently impressed, she will mate with the captain. But why should the assistants help him? Because if something happens to the captain, one of them will have the chance to inherit his position. It may not be a large chance, but it's better than performing solo and having no chance at all. That's enough to show how expert they are, so the captain dismisses his assistants with another special call. If the lady decides to accept him, she will mate with him nearby.
Okay, so notice that it's not just an alpha and a beta, but there's several males involved. And in fact, it can be a whole bunch of males. So you can see over on the left is the greenish kind of looking female, observing this array of male blue manakins courting her. And it really is amazing how responsive the males are to the call of the guy that's going to end up mating with that female. It's going to be coming up very shortly. Now watch what the other males do. There, that call. They just stop instantly. And now they'll disperse. They'll slowly move off and go somewhere else. Cooperative mating, cooperative courtship rather, in the blue mannequin. Now, mobbing also occurs cooperatively in some species, such as this otter.
But confident in their gangs, the otters will actively harass these great reptiles.
Kind of feel sorry for the alligator. I mean, he's just hanging out minding his own business, and these guys come along. By the way, let's see, ferrets do pretty much the same thing. I've seen films of them mobbing snakes, for example. This is an interesting situation that was set up as an experiment that shows how elephants cooperate with one another. Their task, they both have to pull their respective ropes to move a platform close enough to obtain a food reward. If one of them does not pull the rope, what happens is, the way this is set up, here's the elephants over there, there's the platform, and there's food. Okay, now what happens is, if only this guy pulls that rope, that's going to pull this, the rope is going to be pulled through over here, and the platform won't move. And the same, if only this guy pulls the rope, then this is going to be pulled right through and the platform won't move. They both have to pull the rope. So we're looking at from above now. The elephants are being released at the same time. So here they come, and they both grab the rope and they start to pull it. And in comes the platform. There's food in those little red cups, and they're both getting food by cooperating in this fashion. Okay. Now this one I think is even more interesting, because the first elephant, when it's released, has to wait for the other one that's not been released yet to come over to its rope. If this guy starts pulling that rope, it's going to pull it right through and the platform won't move. They both have to pull at the same time. So he just waits. It's got it in its mouth, not pulling yet. And here comes the other one, and now they'll both proceed to pull and get the food. Again, cooperation. So yes, cooperation does occur in a variety of non-human organisms. Okay, let's go back to our scheme here. So suppose that you behave in a way that maximizes your fitness, increases your fitness at least, and by doing so, you are decreasing your friend's fitness, who I guess isn't going to be your friend anymore. We just call that behaving selfishly. You could also think about it in terms of what just happens in just regular competition for variable resources. You're behaving in a way so that you'll get the resources and the other animals won't. Basically, we're talking about natural selection in that case. Now here's one where you behave in a way that actually decreases your fitness, but by doing that, you're also decreasing your friend's fitness. Well, I don't offhand know of any non-human examples of this. In the human realm, we call it spite, behaving in a spiteful manner. But now here's our last one. You behave in a way that decreases your fitness, But by doing that, you're increasing your friend's fitness. And that's where we get to what started out to be the main topic here, altruism. So there's different forms of altruism. So we have our main category, altruism. Altruism, you're helping any individual. Doesn't matter who the individual is. You are somehow jeopardizing your own fitness. It could be just by a little bit, could be by a whole lot, so that another individual's fitness will be enhanced. Parochialism is a special form of altruism. So now we're dealing with subcategories of altruism where you're helping individuals of the same ethnicity or racial group or language group. And this is something that would be only occurring in humans, I think, for probably obvious reasons. Nepotism is a form of altruism where you are putting yourself at risk so that your kin, your close relatives, will have enhanced fitness. Nepotism, subcategory of altruism. So why jeopardize your fitness? I mean, aren't you supposed to behave in a way that increases your fitness? Is this indeed a Darwinian paradox? Is it paradoxical to what you would expect under the rules, so to speak, of natural selection? Kin selection is what's been posited as a way of explaining at least nepotism, putting yourself at risk so that your kin survive. It does not, by the way, explain the general category of altruism, or for humans, parochialism. But nevertheless, it does help us understand nepotism and why at least that form of altruism is not necessarily a Darwinian paradox. Okay, so William Hamilton put forth a theory of inclusive fitness. So again, Darwinian fitness is getting your genes across to the next generation. So for Hamilton, that includes two components. One is, of course, directly reproducing, surviving to reproduce so that your genes get across to the next generation. But it also includes an indirect function where you are actually engaging in kin selection, putting yourself at risk so that your kin have a chance to get their genes across to the next generation. Because if they are related to you, especially if they're your offspring, then they share a certain number of genes in common with you. So it's sort of an indirect way of getting your genes across to the next generation, even if it means putting yourself at risk. But you could also ask the question whether just getting your genes across to the next generation is enough. I mean, let's look at it this way. Here's 3 generations of an animal, okay? And 3 generations of animals, not just one animal, obviously. Generation 1, Generation 2, and the beginning of Generation 3. So we're going from an egg, in other words, embryo, to young organism and adult in the first 2 generations, and then we'll just stop at the egg stage of the 3rd generation. So, okay, going from egg of Generation 1 to the egg stage of Generation 2 is basically the theoretical fitness measure, the way most people look at biological fitness. In other words, yes, you've gotten your genes across to the next generation. Interestingly, the way it's actually studied in most empirical studies is from the adult of Generation 1 to successfully getting to the young stage of Generation 2, in other words, beyond the point of birth, at least so that the young of Generation 2 survive. Or another typical measure is from the adult stage of the first generation to the adult stage of the next generation. In other words, making sure that the young of Generation 2 reach adulthood so that they can now stand a chance of reproducing. So these are the 2 typical measures that we see in empirical studies. Well, interestingly, the geneticist and evolutionary biologists Stephen J. Arnold argued that, maybe we should carry it out to the egg stage of Generation 3. And the reason he argued that is because of the occasional occurrence of hybrids. So where 2 species are able to reproduce and create a hybrid. Hybrids are typically not fertile, which is why, if you carry it out to generation 3, because they're not fertile, they won't get there. And that's why he's suggesting that maybe we should bring it out to generation 3, the beginning of generation 3, because hybrids are not fertile. Guess what? Some hybrids are. So most hybrids would be evolutionarily unfit because they cannot then go on to reproduce, except for those exceptions where they can. So let's look at some successful hybrids.
What are you drawing?
A liger.
What's a liger?
It's pretty much my favorite animal. It's like a lion and a tiger mixed.
So yeah, Napoleon Dynamite's favorite animal is a liger, which in fact is a hybrid of a lion and a tiger, and it looks like that. Now, this is kind of interesting because I think for a while people felt that ligers were infertile. Well, guess what? We now have a lion and liger crossing, producing a liliger.
Meet Kiara. She's the first ever liliger. Well, her dad is a lion and her mum is a liger, a hybrid of a lion and a tiger. Relationships are sure complicated at this zoo in Siberia. Kiara is now in quarantine, but visitors should be able to start seeing her in October.
A liliger, there you go. So there she is as a cub and reached adulthood or young adulthood. Okay, a leopard and a jaguar, get them to mate, and you now have a jagulep. Looks like that. A llama and an alpaca, get them to mate, and you have a huaritzo, and these are typically fertile.
The Aymara's herds are often mixed and consist of llamas, the largest of all the South American camels, and alpacas, which are smaller with a much thicker coat of fine fiber. The huaritzo is the result when these two are crossbred.
And here we have some huaritzos. They do come in different colors, as you see. The ones in this video and photo are white. Well, off-white. Huaritzo. And they are fertile, so they reach generation 3. A goat and a sheep gives you a jeep. And there's a baby jeep. Zebra and a donkey, Z-donk. I mean, these names are pretty obvious how they've come to be named this way. So here we have the two parents over in the back and on the right, and then there's the offspring right there. And sure enough, part zebra, part donkey. There it is from the side as an adult. Zebra and horse. Guess the name. You got it? Zorse.
It looks as if someone tried to give a zebra a respray, then ran out of white paint halfway through the job. In reality, there is no artificial colouring on display here. This amazing but natural coat belongs to Eclise, the Zorse. Her father is a zebra, while her mother is a horse, and she's walking proof of how a child inherits genes from both parents. While most zebra-horse crossbreeds sport stripes across their entire body, Eclise only has 2 such patches, on its face and rear. The 1-year-old Zorse was the accidental product of a holiday romance when her mother, Eclipse, was taken from her German safari park home to a ranch in Italy for a brief spell. There she was able to roam freely with other horses and a number of zebras, including one called Ulysses, who took a bit of a fancy to her. When Eclipse returned home, she surprised her keepers by giving birth to the baby Zorse, whose mixed markings betray her colourful parentage. Horses and zebras are often crossbred in Africa and used as trekking animals on Mount Kenya. Like most other interspecies hybrids, Eclise is infertile.
So they're not going to reach generation 3. So there's our Zorse. A mare and a donkey, a mule. A stallion and a donkey, a hinny. So, okay, altruism was part of that presentation, and in another segment we're going to look further into animal examples of altruism.